Hi, I'm Nyasha. I'm the team leader.
Hi, my name is Harjot Singh and I'm the project manager.
Hi, I'm Michael and I'm the team secretary and
We're
Group 9.
This is a basic description of our Melody app player system. Right? We start off with an Android phone, right? Connected to the first Raspberry Pi, to a second Raspberry Pi, an amp and a speaker. So the user requirements are the user should be able to play a note from the Android app. Right? It's transmitted via Wi-Fi to the first Raspberry Pi. The first Raspberry Pi encodes that data, transmitted via infrared to the receiving Raspberry Pi. Then once it's received to the second Raspberry Pi, it's played via the audio jack to an amplifier and throughout to the loudspeaker.
so our app was developed in Android using Java. In the app, there's a field for the user to enter the IP address of a Raspberry Pi, which I will do here. The user can select two different modes, either melodies or notes. There are individual notes to be played in the volume adjuster. The notes are transmitted as a tuple of the note as a frequency. In this case, we're transmitting the character A, B, or G, etc. The volume, which is gotten from the slider, and the duration, which, as you saw, had the three different variables. Here, I'm going to go to the melodies, and I'm going to adjust the volume, and I'm going to transmit a whole melody of 14 notes to the Raspberry Pi, and that will come up on the terminal.
After the data has been received by the Wi-Fi socket, the data is encoded into a bit stream in the Raspberry Pi, then fed by the GPIO pins into the infrared transmission. The data is transmitted via infrared using the NEC protocol to the infrared receiving circuit, which is connected to the GPIO of the second Raspberry Pi. And this is the data which you can see on the screen being received after being transmitted by infrared.
So once the bits have been received from the first Raspberry Pi to the second Raspberry Pi, the audio is generated using a Java library called JFuge. Audio, once generated, it's output through the Raspberry Pi audio jack, the 3.5mm audio jack from here, to the amplifier, which uses an LM386 chip to amplify the signal with a gain of 200 and then plays on the speaker. So for example, a note is played from here, transmitted, it's received, and it's supposed to play now.
Okay, for the whole system demonstration, I've inputted an IP address into the Raspberry Pi, and I'm now going to play a full melody of 14 notes. So I'm going to press play. You see this transmission starts on this terminal. We're receiving on this terminal, and then the test is successful. We have transmitted from the app a melody of notes to one Raspberry Pi, an IR connection to another Raspberry Pi to an audio amplifier, and that's okay.
The main purpose of this project was to develop a solution for transmitting from an Android phone through to the first IR Raspberry Pi, connect the first Raspberry Pi to the next Raspberry Pi using infrared, right? Then amplify the signal and play it via the loudspeaker. As demonstrated, the system is working, and this system meets the requirements of the user. Right? We can transmit from the Android app to the first Raspberry Pi via Wi-Fi, then from this first Raspberry Pi to the second Raspberry Pi via infrared. We can amplify the signal and we can play it through the speaker. The only problem we faced was a slight delay in the signals being sent and the signals being played.